Okay, so my component was over instruction memory, Julia, by the way. I feel like whenever I started doing this, I didn't really know a whole bunch about instruction memory, and I think I'm just as confused as I was when I started this. But here goes nothing. Okay, so I feel like where we should start is what is instruction memory? Definition that I found, it is a state element that provides read access to the instructions of a program and given an address as input supplies the corresponding instruction to that address. It only stores the instructions in here, and that's where it's gonna, doesn't write or anything like that, just reads in the instructions, and then it'll output into wherever it needs to go. So it sees what the counter thing is looking at, and then it'll take whatever that is looking at, and then it'll give it to wherever it needs to go, because depending on what you're trying to do depends on what data path it's going to follow. I mean, it's always going to go to the control realm where the decoder and stuff is, but whatever's being read, well, it might need to go to sign extend, and I need to go to the MUX or to the register, but just depending on where the data path is depends on where it's going to be sending what was read in. So my overview implementation, I did a lot of research on trying to figure out about implementing it. Wasn't very successful, but from what I gathered, so first things you need to do, obviously, you need to create your module and everything like that, which includes the input memory clock, input instruction address, and the reset and the output instructions. The input signal and output, input signal address and the output signal instructions, there's only 32 bits. They can't be 64 bits because it only brings in 32 bits at a time. That's from what I gathered. Might be wrong though. So you need to create a memory array, so there's a placeholder available where you can store in the instructions. And then there needs to also be, there's like, I think 2 always start instructions, which does the reset and the clock, and does the loop to determine what needs to happen whenever a reset is equal to 1, or the reset is equal to 0, or the clock is equal to 1 and the clock is equal to 0. Issues implementing, I guess my issues mostly were trying to figure out the loops and what needs to be done and how they need to be organized correctly, because honestly going from structural to behavior, a little different and kind of a little confusing, so I didn't really know how to go about doing the behavioral style, and those are kind of where I had some issues trying to figure out how to do that. And then, also remembering to put that finish so that loop, so that it knows when to stop. So behavioral style is the style that was used for my instruction memory. From what I researched, I feel like behavioral style is used mostly for the instruction memory because it there's more control over like what you need to do, because in structural there's not as much control. I mean, it does have to do certain things before it can do another one, but in behavioral you need to these are like directions, instructions, and they need to do something specific in order for it to work out. So that's why I think behavioral style was the reason that I had to use behavioral style for the instruction memory, was because it has more control over what is happening. I think I'm not quite sure, but that's what I think. That's from what I gathered from my research. And that concludes my presentation. Thank you.